before I even start, remember, if you have a B average for the semester going into finals, there's no final for you. So hopefully that might incentivize a few of you who are on the borderline there of not letting Aprilitis get to you. It's easy as we get closer and closer to the end of school to lose motivation. I know too, because that happens to all of us. But you've got to stay focused because we're not finished. We've got this chapter. We have another chapter we're going to start before the end of school. So make sure that you're continuing to be prepared when you come to class, that you're doing your web work on time, you're asking questions when you need help, coming in for help. Don't give up yet. Okay? That not having to take the final would be a nice thing. Okay, so looking at logarithmic functions. Logarithmic functions are the inverse of exponential functions. So who remembers how to find the inverse of a function? We did it last chapter. What's the process? Yeah, you switch x and y, and then solve for y. Right? So if I'm looking at the inverse of 3 to the x, the first thing I'm going to do is switch x and y. And now I want to solve for y. Well, y is in the exponent, so I'm going to convert this to a logarithm. Right? And this would be log base 3 of x is equal to y. So there's the logarithmic function that's the inverse of this. Okay? For me, the way I like to graph logarithmic functions, it seems like a roundabout way to do it, but it's much easier, in my opinion, to do it this way than it is to try and get a table of values using the logarithmic function. What I do is I put a table of values in for this, and then I just switch x and y. And I use that table to graph. Does that make sense? So if I'm looking at this one, because we graphed this one in the first couple sections of the chapter, if I look at a table of values for this function, 3 to the x, that's the inverse of this one that I'm trying to graph, log base 3 of x. 3 to the x, if x is, I think we did these, I think, when we did it the first time. So when x is negative 3, the negative flips it, and it's 1/3 to the third, which is 1/27. When it's negative 2, same idea, 1/8, negative 1, 1/3, 3 to the 0 is 1, right? Any number to the 0. 3 to the 1 is 3. 3 squared, this is, sorry, yeah. I don't know where I got 8. 3 squared is 9. 3 cubed is 27. Okay, so I can use these points to graph the e to the x. 3 to the x function. So negative 3 was really small. Negative 2 was 1/9, still pretty small. Negative 1 was 1/3. Then I went to 1. 1 was 3. 2 was 9. And I'm not going to be able to get 27. But you get the overall idea here, right? So this is the shape of an exponential growth function. What I'm going to do now is I'm just going to switch this, and I'm going to make this y and this x. Because that's how I get the inverse. I just switch x and y. And I'm going to graph these points, and we're going to see what the logarithmic function looks like. Okay? So x is 1/27th, y is negative 3. So really small here, 1, 2, 3. X is 1/9, y is negative 2. X is 1/3, y is negative 1. X is 0, y is 1. X is 0. No, let's do that again. X is 1, y is 0. That's a little better. X is 3, y is 1. X is 9, y is 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 2. So you get the idea? And what's going to happen is the y-axis is now going to be the asymptote. Here the x-axis was the asymptote. Well, we switched x and y, so now the y-axis is going to be the asymptote. And again, the asymptote being that imaginary line that our function will never cross. Okay, so it's a vertical asymptote for the logarithm. It's a horizontal asymptote for the exponential. And notice, if I were to draw in the line y equals x, that's the line that those two functions are symmetric about, which is the definition of an inverse. Okay? So this is just your general logarithmic function. This is a base 3 function. A base 2, all these numbers then would be 1/8, 1/4, 1/2, 1, and so on. Okay? If we look at maybe. These are a couple of examples of an exponential function and its inverse. Okay? This form here, a log base b of x minus h plus k, is the general form of a logarithmic function. If it doesn't shift left or right, it's just going to be log base whatever of x. If it doesn't shift up or down, that x won't be followed by a number, right? So if I had, I guess I'm going to stay green. I have this function we just did. If I want to shift this function to the right 3 units, I would do that. If I want to shift this function to the right 3 units and up 1, it would look like that. Okay? Don't be confused if you see log base 3 of x plus 1. If the 1 is not inside the parenthesis, that 1 is the up and down shift, not the left and right shift. This means the number in parentheses is 0, x plus or minus 0, right? I think in web work, you're going to have to use your knowledge of these transformations to pick the right graph. Okay, so if you knew this is what the general graph of the logarithm log base 3 function looks like, and then instead you have log base 3 of x minus 3 plus 1, it's going to shift this whole thing right 3 up 1, and that would be your new graph. Okay, the other thing that's interesting is if this number b here is between 0 and 1, okay, now the graph, instead of going up, is going to come down between 0 and 1. Because remember, with the exponential graph, if it's 1/3, it's actually a decay. And the inverse of a decay is going to look like this on the logarithm. Okay, because that base, 1/3, is the base in the exponent, and it's the base in the logarithm. And if that base in the exponent is between 0 and 1, it becomes a decay function, which means it kind of flips the shape in the logarithm too. And like I said in the beginning, you're not going to, I mean, it's going to be a lot easier to graph a logarithmic function with a graphing calculator. But you do need to understand the general shape of the function, how it falls. Does it go up to the right normally, down to the left, what its asymptote is, and then how to translate what it means if you put that x minus number inside the parentheses, and what kind of shift up and down, that kind of thing. Understanding that is important. Knowing how to graph a really, I don't know, a complicated logarithmic function, it's better just to use the graphing calculator for something like that. But something basic like this one, I would expect you to be able to do that on a test or quiz. And again, the easiest way is to start with its inverse and then just switch the x and y values. Does that make sense? Let me see if I missed anything. You can see this function is a log base 3 that's just shifted 4 to the right. So it's the same function I just graphed, but because it says x minus 4, it shifts to the right. Okay, so where is the asymptote now? What number is this graph going to go get closer and closer to and never cross? What's that? This is x equals 4. So that's your asymptote, x equals 4. It was x equals 0 on the original, but we shifted it over 4. So with the e to the x, or the 3 to the x, the exponential functions, that asymptote had to do with the k, the shift up and down. With a logarithmic function, it has to do with the h, the shift left or right. So with this function, it shifted right 4 units, so my new asymptote is x equals 4. Okay? With the exponential function, when I graphed that, if I shifted it up 3 units, my new asymptote would be y equals 3. So it has to do with the, I want to do exponential. If I shifted it up 3 units, which is what this means, my new horizontal asymptote on the exponential function is y equals 3. With a logarithmic function, the shift happens in the parentheses left or right. That's your new asymptote vertically. So that's kind of an easy way to find the asymptote, is look for what the shift is. Whatever it shifts left or right is your vertical asymptote. If it's an exponential function, whatever it shifts up or down is your horizontal asymptote. Okay. Finally, let me just go through here again. You can tell this one flipped and is going down to the right because the base is 1/4. It's between 0 and 1. And if you're going to graph a logarithmic function that doesn't have a common log, like 10, base 10, that's what the calculator understands. You're going to have to use the change of base formula. So if I wanted to graph this function, which was log base 1/4 of x plus 2, how do I use the change of base formula? Log of base 1/4 of x plus 2. What's the change of base formula? What do I do?
Log x plus 2 over log 4.
Okay, you're close, really close. You're going to do log of x divided by log of 1/4 plus 2, added to the whole thing. So it's going to look like this. And if you put that in the graphing calculator in that y1, it'll graph it for you. But if there's no way to put this in for y1, so you're going to have to use the change of base formula if you want to graph it on a calculator. Okay. Anything else here? This one, example 4, is an interesting one. They wanted to know if negative 2, 1 is on this graph. If you plug negative 2, 1 into the function, you actually get an unequal 1 does not equal negative 1. That's a way to prove that it's not in the graph. Can you take a log of a negative number? Let's figure it out. This is, let's just set it equal to x. This means 3 to what number is negative 2? Is there any exponent I could raise 3 to that would turn that number negative? My negative exponents flip it. They don't change the sign, right? A negative number here is never possible with logarithms. Is not undefined, does not exist. That'll come in handy in the next couple of sections. Okay, let's go through the textbook check real quick. And this is 8.5. So because the logarithmic function is the inverse of the exponential, it will have a horizontal or vertical asymptote. vertical asymptote. Exponential has a horizontal. Logarithmic will have a vertical. If this is the general form of the logarithmic function and b is between 0 and 1, the graph will move down to the right. To graph a logarithmic function that is not a common logarithm in the graphing calculator, you'll need to use the change of base formula, true. In this general form, if h is 3, it means a shift right 3 units. And finally, the videos in this section were by Mr. Witt. They were by Khan Academy, so that's false. Okay, any questions on 8.4? That one hopefully went pretty well, just going back and forth between exponential and logarithmic functions. And then I think there was a change of base question or two in there too. So, okay, that's it.